Let's take a moment to talk about products and exponents and how they're related. Let's say you have 2 to the third power times 2 to the fifth power. What would this equal? Well, you can just type this into a calculator and it would give you an answer, and that's fine. But to actually understand what's happening, let's take a moment to talk about what these mean individually. 2 to the third power is a factor that we're multiplying here. And what 2 to the third power represents is repeated multiplication. So 2 to the third power, or 2 exponent 3, means a product of 3 2's. Similarly, 2 to the fifth power is another product of 2's, and there are 5 factors of that too. So ultimately what we're asking is 2 to the third power times 2 to the fifth power is, what is the product of 8 2's, right? If I just count them, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 2's that we're taking the product of. So before we even talk about the actual answer, we could rewrite this as another power. This would be written as 2 to the 8th power. So for those of you who've actually seen some of this in algebra, this might sound really familiar. This is actually a rule you've learned in algebra where you can say something like the following. If you have a value a and you raise it to the power, let's say, x, and you multiply it by the same base, right? We call this value a the base of a power. If we raise that to a different exponent, then in general, we can say that this would be the same thing as a to the x plus y power, right? So when you take the product of two powers with the same base, I'll make a little note of that, same base, then you just take the sum of the exponents. Let's look at another thing that can happen with exponents. Let's say I want to find the quotient or the division of two powers. So I have 3 to the 8th power over 3 to the 5th power. Yes, a calculator would suffice here, but let's actually write out what this expression means. 3 to the 8th power means I have the product of 8 3's. And I'm going to divide that by the product of 5 3's. So what we have here is factors of 3 dividing other factors of 3. Now, in general, when you divide a factor by another factor that are the same, any factor divided by itself is 1. So every 3 over 3 that I have, we might say that cancels, but 3 divided by 3 is a 1, so this actually becomes a factor of 1. And the reason why you might see teachers or other videos show that we cancel and there's nothing left is because if there's a factor of 1, any other factor times 1 would still be itself. So that one factor is not really necessary to write, but it can be helpful if you're simplifying expressions and you're not sure what it technically means to cancel. I think it's a little safer to just explicitly say you have a factor of 1. So, okay, let's continue dividing factors of 3 by themselves. And we'd have another factor of 1 here, another factor of 1 here, another factor of 1 here, and another factor of 1 here. So essentially what I'm left with is I have 3 times 3 times 3 times 1 times 1 times 1 times 1 times 1. Because of the properties of multiplying by 1, I can essentially ignore those factors of 1. And what we're left with is 3 to the power of 3. Because I have 3 factors of 3 left over in my product. And I'm not dividing by any more factors of 3. So that's why in general, you might see textbooks or other videos or even your teacher show you a property of dividing powers that looks like this. If you have a to the x power divided by the same base, a to a different exponent y, we would write this expression as the difference of those exponents, right? Because we had 8 factors of 3 on the top here, and we had 5 on the bottom, and look how many we had left over, 3. So in general, we can say that the top exponent minus the bottom exponent when you divide powers is the result. So this would be x minus y in that case. So a very similar property to the one we just did. When you take the product of powers, you find the sum of the exponents. But when you take the quotient of powers, you take the difference of the exponents. Lastly, let's look at another example here. What if you had 5 to the 3rd power to the 4th power? So what happens when you raise an exponent to another exponent? Or I should say, what happens when you raise a power to another exponent? Don't overthink this too much. Anything to the fourth power just means a product of 4 of those factors. So if 5 to the third power is my base, right? This is the base of my power. Then I'm raising that to the fourth power. I have a product of 4 of those bases. So this actually would become 5 to the third power times 5 to the third power times 5 to the third power times 5 to the third power. Now, if we just reuse the rule that we came up with in the first example by finding the product of powers as the sum of their exponents, I could actually rewrite this as a sum of all of these exponents. So what I could rewrite this as is, and since they all have the same base, I should say, right? So since they all have a base of 5, 5, 5, 5, I could write this as the sum of all of their exponents. So it'd be 3 plus 3 plus 3 plus 3 will be my new exponent. And just adding those 3's, you get 5 to the 12th power. And if you find that kind of interesting, you should, because our original problem had us take 5 to the third power raised to the fourth power. And what we ended up doing was we found the sum of 4 3's, which repeated addition is known as multiplication. So again, coming back to another rule that you may have seen previously, a, that's non-zero, and you raise it to the power of x, let's say. And then you raise that power to the power of y, given an exponent y, that's equivalent to a to the x times y. So you take the product of the exponents if you raise a power to another exponent. So in general, you might just want to learn the formulas or learn the rules about exponents, but I wanted to take time to make a video to actually show you how you can kind of make sense of why these rules exist.